Hello, everyone. Welcome to the new episode of the series In Conversation with. Today's topic is the impact of AI on storage and networking infrastructure. My name is Aiswarya Soman, and I'm the director and co founder of Open Innovation India. AI has been rapidly evolving, pushing the limits of existing storage and networking systems. With the explosion of the unstructured data, the need for high speed processing, and the demand for real time AI inference and an infrastructure supporting these workloads has never been more critical. To help us navigate this complex yet fascinating topic, we have with us Mr. Prashant Kulli, an engineering leader with over 18 years of experience in software development, maintenance, and customer experience. Prashant has been working in the storage data path at leading companies such as EMC, Nimble Storage, and HPE. His expertise spans across the entire storage stack, ranging from application and host side file systems to array side file systems. Prashant is also completing his Stanford lead education in March. Prashant was inspired by two guiding principles from Nimble Storage's founders and leadership team. That is, don't change the customer, make the product better, and never debug the same issue twice. These have driven significant innovations at Nimble Storage, now HPE, improving customer experience and engineering efficiency. He has been a major part of building HPE's unstructured storage solution called MPX 10000, announced recently by HPE Discover. Currently, he is focusing on building next set of data path features for the same. Welcome, Prashant. Great to have you join us today.
Hey, thank you, Aishwarya, and really happy to be a part of Open Innovation India. Thanks for this opportunity. Looking forward to it.
Great, great, great. To kick things off, could you tell us how are AI workloads pushing the limits of existing storage and networking infrastructure?
Yeah, that's a great question, Aishwarya. So AI workloads, right? They bring in fundamentally different kind of workload. They are different than the traditional workloads that used to hit the storage systems, right? So how are they different? They are different in terms of the amount of data, the variety of data, and also the velocity at which they are coming into the storage. So they are fundamentally different in that aspect. Now, with AI training data sets that are growing like exponentially, right? And also all these models integrating, the text, images, and videos, they are only pushing the existing storage solutions to their like limits, right? And AI workloads, they demand like really high throughput and low latency, right? And that's where things like computational storage and a lot of in-memory processing and technologies like NVMe, they become very essential. Um, let's also look at storage endurance itself, right? So what is storage endurance? Now, if you have worked in storage, you know that the solid state drives and the hard disk drives, right? Traditionally, they have a wear out period, like over a period of time when they are done processing, a significant number of reads and writes, they wear down. Now, with AI workloads pushing the limits, these devices are going to wear out faster. So, which means we will need to come up with, storage solutions that are more durable, right, in that aspect.
That's great. That's insightful, Prashant. Thank you for sharing that. Given these challenges, what do you think are some common solution to address this I/O bottlenecks in AI-driven storage systems? If you could share that with us.
Yeah, that's another good follow-up question there. A common solution to address I/O bottlenecks, right, is basically you have to utilize more and more NVMe, SSDs, and all flash storage systems, right? Basically, these storage solutions they improve the latency and throughput significantly. Now, the question is this enough? All right, probably not, because in the last decade, most of the storage solutions have been storage infra vendors. have been implementing these kind of all flash storage systems. But what we need right now, in addition to this, is the very strong parallel file system, or you can call it as a distributed storage. Uh, that can provide you large concurrency, because the AI-driven workloads, they require higher concurrent access to the storage systems. So that's where I think that's one of the solutions where you can address this uh, need. And also the data prefetching and the caching strategies, right? Because we are talking about low latency here. So how you prefetch and how you strategize your caching going forward, making those pieces intelligent, is going to be key in addressing these bottlenecks.
Absolutely, that makes sense. And it also ties into networking, right, which is equally critical for AI. So, how is networking infrastructure evolving to support AI's bandwidth and latency needs?
Yeah, absolutely. So networking, is definitely undergoing a lot of transformation to support the AI workloads. Now, when you think about traditional TCP/IP workload, definitely that is struggling with the amount of AI data that is going across the wires these days, right? And that's where you might have heard some buzzwords like RDMA. The technologies like that are coming into place, like RDMA is basically remote direct memory access. And coupled with RDMA, we also have something called as GPU direct storage. If you look up into NVIDIA website, there is a paper about GPU direct storage. Basically, it eliminates it eliminates going through the CPU and system RAM to transfer the data from the storage to the GPU memory directly. So it's a direct access to the storage into the GPU memory. So that is also a fascinating thing that is happening. I'll add one more thing, right?
Sure.
Because we are talking about network here as well. So talk about this AI-driven SD-WAN itself, right? The software-defined WAN that is optimizing the AI workload traffic across the cloud and the edge environments. And also, we are seeing significant demand going up for 400 gig plus and optical networking to handle this, AI intensive workload. So that's on the, some of the things that are happening on the networking side.
Absolutely great. And I wanted to check with you with these advancements, what are some of these emerging storage and networking architectures that are designed specifically for workloads? If you could share that with us.
Yeah, definitely. I'm happy to talk about it. There are a lot of fascinating innovations that are happening in this space, right? One is definitely the computational storage. What we are going to do is basically we are going to offload some processing to the storage layer itself. Now, storage is not dumb anymore, right? Like storage has to own certain piece of, the AI data pipeline, right? So that is computational storage. And then we have disaggregated storage that is becoming very popular. And I am happy to share that the MPX 10,000 in HP that we delivered recently is the disaggregated storage solution. So what is disaggregated storage solution? So we are decoupling the compute from the storage, right? So that you have flexibility in growing the solution on demand as per the AI needs, right? So if you want more storage, you can add more, flash enclosures in the backend. If you need more compute power, you can add more compute nodes on the top layer. So you can scale horizontally, either the compute or both, if that makes
Uh,
sense.
Absolutely, this is really great. And it's clear that infrastructure is evolving rapidly to keep up with AI, right? But with all these advancements, we would like to know what are the challenges do infrastructure providers face in designing a future-proof solution or solutions?
Yeah, again, it's a very crucial question. Definitely, I have to talk about sustainability, right, for the storage infra vendors. So many companies have signed up that they have pledged that they will go carbon neutral in years to come, right? Not in a not a very
Yeah.
distant future. So sustainability is going to be challenging because AI, AI workloads demand larger number of resources, such as power, for example. Uh,
Mhm.
so that's going to be challenging in my opinion. And also, are we ready for the AI growth, right? Now think about models like GPT-5. They may consume like 10x more power or no more resources. So being ready for those kind of things is challenging. And let's talk about the interoperability itself, right? Like the AI workloads are spread across different layers, right? Like they are in cloud, they are on premises, they are on the edge where the devices are actually producing the data. So making the integration between these pieces seamless is going to be challenging. um, and then next thing definitely is security, right? Because AI is processing massive amount of data, and we should definitely know that a lot of this data can be user or customer sensitive, and how do we protect it using the robust encryption technology and provide the access control to that sensitive data. That's going to be a big challenge. And finally, the biggest challenge storage vendors are going to have, or the infra vendors are going to have, is how do you provide faster infrastructure or a high performing infrastructure without breaking the budget or keeping your operational costs in check, right? I think that's going to be pretty challenging. These are the challenges I think everybody is going through right now, and I hope some nice solutions come out of it to address a few of these or all of these challenges.
Excellent. Thank you, Prashant. This has been an incredibly insightful discussion. Um, thank you for sharing great examples from your current work and also from your past experience. And we are really glad to have you here. To summarize, we have explored how AI is pushing storage and networking to their limits, the bottlenecks in current architecture, the solutions, the evolution of networking infrastructure, emerging solutions designed for AI, and the challenges in building future-proof infrastructure. It was great having you here, and thank you so much for sharing your expertise with us today. And thanks to our audience as well for joining us. Um, any parting thoughts from you, Prashant?
No, this is great. This was a great conversation. Yeah, thank you so much for this opportunity. And, I wish you guys all the best, and happy to be a mentor in this Open Innovation India Forum. So thanks.
Amazing. Thank you so much. We are very glad to have this partnership. To our audience, we will be back soon with another engaging conversation on the future of AI-driven infrastructure. Until next time, keep inspiring and keep innovating. Thank you.